post this for people who are not here, but this is going over the notes for the test. So here we go. I'm going to head right over here and show you what we got. This is the, I'm going to get my Spark going here. There we go. All right. So at the beginning of your notes, you know what, Jacob? If you're going to keep doing that, I'm going to turn off your video. All right. So let's see. The first part of your question is vocabulary, where you need to recognize the reactions. Now, on the test, you're not going to have all these A's and B's and C's. What you will have is elements that look like they're combined and written in a form that is a molecule. And you'll just need to be able to watch. And if you see something that says synthesis, what synthesis is when you have two separate molecules or atoms on one side, and then you have the arrow. I'm going to make this one a little smaller here. And you have this arrow that goes to the next thing, and then those two things are combined. So if you see that in a chemical equation, you know that's a synthesis equation. All right? A decomposition equation is just the opposite. You'll see one molecule that has two or three different atoms stuck together, and then it goes to, and it's going to have a little arrow like this. It goes to them two separate. It's called decomposition or separating. All right. Now, a replacement equation is when you have one little piece or one element right there combined with a molecule that has two or more elements, and there's a switch going on. This A connects to the B now, and the C is all by itself and lonely. That's called a replacement. That A is replacing the C in that molecule. Now, in a combustion, now I wrote this down wrong in your notes. I spelled it incorrectly. So it wasn't combustion, it said composition, but it really should be combustion. So you may want to change that in the document. But a combustion will always have oxygen on the left. So you'll always have something plus O2, and then when it's done, you'll have something plus carbon dioxide. All right, and that's going to be your combustion equation, your combustion chemical reaction. That makes sense? Oh, whoa. Let's erase all of this so I can move up. All right. Now, things to know. The first one, recognize when a chemical equation does not demonstrate conservation of mass and is not balanced. All right. So when both sides of the equation do not have the same amount and kind of element, it's not balanced. And then that means it does not demonstrate conservation of mass. So you'll have examples of some chemical equations, and you're going to have to do the math and count the number of carbon atoms on one side, the number of carbon atoms on the other, the number of oxygens on one side, and oxygens on the other, or whatever, to make sure there's the same number on either side of the equation arrow. It's kind of like the equal sign. All right. Next question is number 2, recognize the difference between a physical change and a chemical change. That's pretty straightforward. A physical change is only a change in shape or state, either a liquid gas or a solid. And again, I'm recording this, and so I'll post it and you can just review it and look at it over and over again. That's a physical change. A chemical change is a rearrangement of molecules like what we showed you up on the top. That's the difference between a chemical change and a physical change. All right, third question. 3 ways to increase the rate or speed of a chemical change. That's kind of what I went over yesterday with the lesson yesterday. The three ways are an increase in temperature. Raise the temperature, molecules are moving around faster and bumping into each other faster, and so the chemical reaction is going to go faster. Increase the concentrations. If there's more of the reactants, then there's more likely that they're going to be bumping into each other and making new things. And then increase the surface area. In the video yesterday I did about the last lesson in chapter 14, we talked about how if you have a tablet like an Alka-Seltzer or a Fizzy and you drop it in water, it's going to take a certain amount of time to dissolve and bubble up. But if you break it into 5 or 6 or 7 or 8 pieces, it'll go faster because there's more contact between the two areas. All right, so that's number 3. Yes, Selah, you have a question?
Down.
What was that?
Can we write this down?
You can write it down. Let's see, I think I need to stop someone from writing on my board here. And I'm going to stop sharing. Yes, thank you for stopping that. All right. All right, number 4. What change always indicates a chemical change has occurred? It's pretty easy when it makes something new, right? When it makes something new. Number 5. How does a catalyst change? How does a catalyst change the rate of chemical reaction? It will help line up and orient the molecules to connect them in a way. All right, somebody's sound is on. Maybe idly do these, whoever you are. All right. Number 6, what substance is always one of the reactants in a combustion reaction? Short, simple answer. Oxygen is always there in a reaction. Okay. Number 7, what type of chemical reaction always has only one product? Synthesis reaction. Okay.
I just need you the best one.
Selah, can you mute your, there you go. Number 8, this is one that we just got through talking about. How will grinding a solid into a powder affect the reaction between a solid and a liquid? It's going to increase the surface area so that more of the reactants are in contact with each other. All of these so far have been multiple choice questions. The ones that we're going to start going over now are going to be short answer. So you may want to have another window open to write these down, or when I post the video, you can look at the video, pause it, and type stuff on your notes. All right? So short answer question number 1. Why does decreasing the temperature of a reaction change the reaction rate? And I goofed up here. It doesn't speed it up, it slows down. Okay, by decreasing the temperature, you're slowing down the motion or kinetic energy of the reactants so that they collide less often. And I will change that. Actually, you should change that. All right, so decreasing the temperature of a reaction slows it down because they're bumping into each other less often, those are molecules and atoms. All right. And the next one, number 2, in an experiment, the student places a 10 milliliters of vinegar in a cup. Student places a thermometer in the cup, then adds 30 grams of baking soda. The resulting reaction decreases the temperature of the mixture. What type of chemical reaction is it? Endothermic. The temperature goes down. Endothermic. All right. Next one, number 3. What's the first thing that must occur for two molecules to react with one another? Pretty simple. They have to collide or bump into each other. They have to bump into each other. They're not going to react if they don't bump into each other. All right. Then number 4, how does the law of conservation of mass apply to a chemical reaction? Chemical reactions will always have the same amount of each element at one end of the reaction as on the other. So when you have your reaction with your things plus other things on one side, you're going to have the same amount of carbon atoms, the same amount of oxygen atoms. You kind of have to count and make sure that you've got everything all balanced. All right, so let's see if I can erase all of this at once. There we go. Now, number 5, write a balanced chemical equation for the combustion of methane. This is the methane. And air, this is air. Air always comes in pairs. That's why there's this pair right there. All right. So I have 2 of those molecules. Now, how is this balanced? How are we making sure this is balanced? Well, if I count my carbons, I have only 1 carbon on this side, and I have only 1 carbon on this side. So that part's balanced. And I couldn't really draw this. Let's make an arrow there so it works. All right. So carbons are balanced. Do I have 4 hydrogens? Well, let's see. I only have a little 2 there, but I have 2 of the molecules. So what that's telling me is I have 2 molecules, and each molecule has 2 hydrogens. So yeah, so I've got 1 carbon on this side, 1 carbon on that side. I've got 4 hydrogens on this side. I've got 4 hydrogens on this side. Now let's look at oxygens. I have 2 oxygens in each molecule, and I have 2 molecules. So now I have 4 oxygens. All right. Let's see if I've got 4 oxygens over here. I've got 1 molecule that has 2 oxygens in it. And then I have only 1 oxygen there in that molecule, but I have 2 of those molecules. So that's 4 as well. That's 4, 5, 6. Uh-oh. Actually, it's not 4, 5, 6. Sorry. This is 2, and this is also 2, because I have 2 molecules, and each molecule has 1 oxygen. So that's also 4. So I have 4 oxygens. So it's balanced. So now if you wrote this, you would have a balanced equation. Use the arrow. You have 1 molecule of methane plus 2 molecules of oxygen. It's going to give you 1 molecule of carbon dioxide and 2 water molecules. It's balanced. All right. Now, coming up, the essay question. And again, I will post this on YouTube, and you can write it down and look at it over and over again. The essay question says, sugar can be converted into carbon dioxide and water by burning in air or by metabolic reactions inside living cells. How are those reactions similar? How they're different? You want to write something like this. Sugar is converted into carbon dioxide and water in living cells and by burning in air. You can burn sugar. You can actually use sugar to make a bomb. It's kind of weird, but anyway, it says both of these processes use the same reactants and get the same products. You start with the same stuff and you end up with the same stuff. Both are also exothermic reactions that produce heat. Okay, when you burn something, it makes heat. When your body burns sugar, it's producing heat and energy to keep your body alive. And then the difference is the cell uses a catalyst. Remember, a catalyst helps a reaction happen faster and more efficiently. The cell uses a catalyst, and this can be done at a much lower temperature, all right? And so your body's burning the sugar at a lower temperature and in a controlled way. And that's all you need to write, okay? That's all you need to write. So again, I'm going to stop sharing now. trying to stop sharing now. Let's get rid of that. Stop sharing. I'm going to unmute you guys. Any questions on that?
Oh, yeah. No.
All right. I'm going to post this real fast on YouTube, and you can pause and start it to get it down on your Google document. And we will work on getting you guys ready for the test on Friday. It's not going to be a hard test. All right. I've been noticing many of you haven't yet started on course 1 math test or the course 2 math test. Can you see the math test all right on Google Docs?
See right there.
What was that?
Hi, Dad.
Hey, Micah. Can you see the test on Google Docs, or have you tried looking at it yet?
Hmm?
The math test.
I haven't done it yet.
You haven't tried yet?
No.
Have you tried yet, Jacob?
Tried what?
Doing the math?
Not really. No.
Matthew, have you tried doing the math test? All right, so you can see it all right? All right. All right, I'm gonna end the meeting. I'll just save this and post it, and you guys can figure out your notes and get your notes done. See you guys. Oh, let's see. You had your hand up, Selah?
No, apparently.
All right.
No, wait. Mr. Nelson?
Hey, Jacob, I can shut your video off anytime. Yes, Selah.
For the Nelson notes, are we supposed to finish those by using the YouTube?
I'm not going to do any Nelson notes this week. I'm just going to communicate through meetings and YouTube. Next, after spring break, I'll start doing the Nelson notes again.
And for the science notes, do we finish that through YouTube?
Yeah, I'll post what I just did, and you can watch it and pause it, and then go to where your Google Docs is and finish your notes.
Okay.
All right? See you guys later.